Hello everybody, today we're working on Packet Tracer Lab 4.7.1, Physical Layer Exploration dash Physical Mode. There's a lengthy explanation in the beginning of this lab that I'm going to let you read on your own, but basically this lab is about how computers communicate with each other or with servers and what they go through in the process on the network to reach each other. You're going to spend a little bit of time examining your own computer and its IP address. And then we're going to spend a lot of time here on this scenario that they've set up for us. It looks like a regular office. And here we are in physical mode. So get all your materials together and let's get started. After this lengthy description here and the requirements, we have the instructions that begin with examining the local IP addressing information. So in step 1, we are examining this idea, what is my IPv4 address? And it explains here your IP address is used to identify your computer when sending and receiving packets, similar to how your home address is used to send and receive mail. You can use the ipconfig command on Windows and ifconfig if you're using a Mac operating system and Linux. So this activity, it says, opens inside the home network. And so what they mean by that is up here we have this page that shows us this office is listed and named as the home network. So that's what they're talking about. They've created this office situation for us. Part A says click the home PC sitting on the desk and then click desktop tab command prompt. So let's find that home PC. Can you see the device name there in the first line? Home PC. So left click on home PC and then we're going to click the desktop tab and then command prompt. I'm left clicking on everything. And then we want to type the command ipconfig and hit enter. And you can see that this information matches what's printed out on this lab for us. We've got, they've got the IPv4 address highlighted. That's this one that ends in .75. And the default gateway is also highlighted. It ends in 0.1 there. And so those are the things they want us to really notice about this. And then it says repeat this same thing on your own device. So in order to do this on your own device, what you would do is in your search bar, type in command prompt and choose it. And you'll get your actual computer command prompt, just like we do when we're in Packet Tracer and we pretend we're on a command prompt. This is the actual command prompt. I use Windows, so I can go ahead and type ipconfig and then enter, and I'll get information about my IP address and my default gateway. So they ask you to do that. And then for part C, they want you to answer what is your IPv4 on your actual computer and what is your default gateway. So go ahead and list those. And then we will continue on here in this part of the lab to step 2. What is the IPv4 address for my router? This same Windows ipconfig command shows the IPv4 address of your local or home router, also known as the default gateway. And it gives us another way that you can find it by typing the -n to get your router if you're using Mac or Linux. And then they want you to list your IPv4 address for your router. That's your default gateway, and I already showed you how to do that. Okay, so then let's move on to step 3. What is my public IPv4 address? So private IPv4 addresses are not routable on the internet. When IP packets leave your network, they need to have their private IPv4 address replaced with a public IPv4 address. The public IPv4 address is used by servers or any other destination to send packets back to your client computer. Where does this translation between private and public IPv4 addresses occur? Your local router does the translation for you. So that's one of the router's jobs. How can you find out the public address that your local router substitutes for your private IPv4 address? And then it's got instructions for you on your device. Search the internet for what is my IP, and you'll get some choices. You'll be able to see what your IP address is. But in Packet Tracer, close the command window and then click the web browser. So I'm Xing out right here and I'm going to the web browser. And then I want to type www.tellmemyip.com. Go. This doesn't actually exist. It's fictitious. They tell us that in the directions, but here it went ahead and told me the IP address. It's even got the geolocation. On your device, use one of the What is my IP websites you found in your search and list your public IPv4 address, location, and your internet service provider. So go ahead and do all of that on your actual PC by actually searching on the internet to find out what your IP address is. Okay, step 4 then, examine the connections in your network. What does the connection look like between your device and your router? Do you have a wired connection or is it a wireless router that you're connecting to? Answer that question. Where is the router that your device uses to access the internet? Mine is on a tabletop. It's a wireless one and it's around the corner from me. What does the connection look like between the router and the internet? Does it use a cable? Is it wireless? Can you find the cable as it leaves? So go ahead and investigate your actual computer and your setup. How is it connected to the internet? If I walked over to my router, I would see that there's a cable that goes into the wall that my internet service provider has provided for me. And then they have a YouTube video for you to look at if you want some more information about that. Okay, part 2, trace the path between source and destination. In this part, you will use traceroute command that is used for network diagnostics and for displaying the path packets take to a destination. It gathers information about every hop from your device to the destination. Each line in the output designates the IP address of a router used to forward packets from one network to another network. These are known as hops. In Windows, the command is traceRT, whereas the Mac OS and Linux operating systems use traceroute command. In Packet Tracer, you use the Windows traceRT command. The hops are simulated, so all of this is just pretend. However, they adhere closely to the actual path that the data would take between a device in Monterey, California, and the web server at the University of Hawaii in Honolulu. Note, during this part, you will be investigating the output for 2 trace routes. One will be from the home PC inside Packet Tracer. The other will be from your own personal device. So once again, you're going to mirror what we're doing in Packet Tracer and try it on your actual computer. Okay, in Packet Tracer, on the home PC, close the web browser window if it's still open and open the command prompt. So I'm going to X out right here and go to the command prompt again. And I'm back here at my prompt and I want to enter this command, traceRT space www.hawaii.edu, and then hit enter. And what it is doing is it's finding out how it gets to that server in Hawaii. What is it doing? What are all the hops? What are all the addresses it's going through? How long do all of them take? And it says you can click fast forward to speed up the process if you want to. But we're already done here. And then part C says, on your laptop or other computer, open a terminal window and enter the traceroute command for your operating system. Your output will be different from the output below and the output in Packet Tracer. Your output will most likely show the names of real routers and public IPv4 addresses. Unless you live close to Monterey, California, you will likely have different router names, IPv4 addresses, and a number of hops. So go ahead and do that. It's a very interesting thing. Go ahead and do it on your real computer and see what kind of information that you get on your computer. Where is it going through? It can be a very interesting little process. Here in part C, it shows an example of what this output could look like, where it shows details about where these routers are, what their IP addresses are, and the hops. And it shows that this is going to take too many hops, and you can end it quickly by hitting Control C to end the trace route. Otherwise, it'll keep going, which is fine too. But the trace route begins to time out in this example because the router at the end of the path is most likely configured to not reply to trace route requests. So if that happens to you when you're doing a trace route, that's what's going on. Sometimes the servers that you're ending at don't allow for traces. Look closely at the first line of output. I'm on step E now. The three numbers preceding the IP address are timestamp values such as 3 milliseconds, 4 milliseconds, 5 for the first hop. This is the round trip time between the source device and the router of that IPv4 address in milliseconds. Okay. Some hops may also include domain name information. And then although the output timed out before reaching the server at hawaii.edu, the prior hops provide enough information to trace the path of the packets. On your device, try tracing the route to other websites, such as www.netacad.com or www.google.com. Some hops will probably time out. Some web servers may not respond to traceroute. So go ahead and give that a try on your real computer. All right, step 2. Investigate the second hop in the traceroute output. The traceroute shows a second hop that looks like this. So do you see it here in line 2? Back to our packet tracer that's going on. The IP packets now leave the home network and are sent to the ISP. The 10.120.89.61 is the IPv4 address of the first router outside the home network. So this here is the home network. I know that because look at the default gateway up here. It's the same as this one. And this second line is the first hop away from that default gateway. The physical net connection between the end user and the POP, point of presence, is known as the local loop, or is sometimes referred to as the last mile. Traditionally, the local loop was the telephone lines from the customer's premises to local telephone exchange, sometimes referred to as the central office. The copper twisted pair cables were used to carry analog voice and signaling information. Today, the local loop may also include cables to carry digital information, which can be wired or wireless. In terms of internet connectivity, the local loop connects the customer's premises to the ISP POP, point of presence. The local loop may be one of several different types of connections. It could be cable, DSL, wireless, satellite, fiber optic, dial-up with a telephone. In Packet Tracer, notice the home PC on the desk is connected to the home router on the shelf behind the desk. However, the home router is not connected directly to the router at the next hop. Instead, it's connected to a cable modem. This cable modem is not a router, therefore it is not reported as a hop in the trace route output. So let me minimize this a second and let's see what they're talking about. See this home PC? It is connected to the home router on the shelf behind the desk. So let's look right here. There's our home router. And they're even showing us a cable here. See this green cable? It's going over here and following up to the home router. That's what they're talking about, okay? Okay, so here we are in our home network, and next it says to navigate to Monterey. So we need to back out of this. See this back button here? We're going back a level to a map, and this is Monterey. That's what they're talking about. Notice that the next hop is physically located linked to the Comcast POP building. So here's our home network, and this right here says Comcast POP. Click Comcast POP. A POP is physically located in a data center. A data center is a physical facility that organizations use to house their critical equipment, applications, and data. The key components include routers, switchers, firewalls, storage systems, and servers. Although the Comcast POP would typically be a data center in the real world, in Packet Tracer, it is only storing the equipment necessary for this activity. So this is a small version of what an internet service provider would have. In the rack, you will see several devices, including a device simulating a cable modem termination system, the Comcast POP Monterey router, a multi-layer switch, and 2 servers. So we've got a lot of things going on here. Investigate the physical connections between the devices. One interface of the Comcast CMTS is linked directly to the cable modem in the home network. The other, so let's take a look at some of these. Let's hover over them. This is the CMTS. Here is another cable. Take a look at those details. Here is the connection between these two devices. There's a multi-layer switch connection. Here we're going to a server and another server. In your own network, what is the technology for the local loop you are using? Are you using cable, DSL, satellite, cellular? So go ahead and answer that question. The second hop in your traceroute command on your device is typically your ISP's hop. What is the address? So go ahead and look at your device information. What is your second hop? And what is that address? That is probably your internet service provider's POP. All right, step 3, attempt to discover the physical location of the IP address for your ISP POP. And here they give you a table for you to enter all of that information into. So go ahead and fill in this information. Find out your results for your device. And then they have you searching the internet in step 4. Investigate why geolocation information is not always accurate. So they have you doing an internet search here, an internet search, and you're going to find articles about this, and then you'll understand why you should be skeptical of any geolocation information that shows packets going from one location thousands of miles away and back again. Okay. And then in step 5, investigate the local ISP network. For the example of real traceroute output shown below, so take a look at this information they give us from a real traceroute from a real computer. Recall that the real IPv4 addresses for these routers have been modified for this activity, so you can't use them in an IP lookup situation. You can't Google these. However, you can look up the IP addresses for your own traceroute output to determine how many hops belong to your internet service provider. And we're back to Packet Tracer. It says in Packet Tracer, navigate to Monterey. So let's go back out again. This time we want the Monterey.ca building. That's right here. Notice that the 2 routers in the rack belong to Comcast.net. And you can see it when you hover over it. It's in the device name. What is the IPv4 address of the third hop in the Packet Tracer traceroute output? And that is the same as this first address here in the Monterey rack, the first router. It ends in .133. It's that first, I don't know if I can still, no, it disappears if I try to show you, but see that first gigabit Ethernet 00? It's that IP address. That's the answer. All right, the next question, which router and interface in the Monterey CA building is configured with this IPv4 address? It's the first top router here, and it's gigabit Ethernet 0/0. What is the IPv4 address of the fourth hop in the packet tracer trace route output? Well, that was the second router, if you look back at it. It's the one that ends in .129, so 10.139.198.129. Which router and interface belongs to this? It's the second router, and it's gigabit Ethernet 0/0. Why do you think the IP addresses for the other interfaces are not shown in the traceroute output? And that's because those are used by other devices. List the hops in your own traceroute output that belong to your local internet service provider. So just list the numbers of those. When I did this once before, my hops were 4, 8, 9, and 10. Those all belong to my local internet service provider. Okay, step 6, investigate the domain names in the output to discover more clues about the location of routers at each hop. The domain name, if there is one, in the trace route may provide additional information. There is no standard naming convention. If and how it's used is solely up to the discretion of the administrator of the device. In traceroute output above, Comcast has provided information in the domain name that gives you a clue about where the router may actually be located. So here's how they've highlighted those areas for you. It looks like they're giving you actual cities in California. We have made the assumption in Packet Tracer that all routers with the same city and in the domain name are in the same data center. For example, as you have seen, these two routers are in the Monterey.ca building. What information, if any, can you decipher from the domain names of your local internet service provider? In Packet Tracer, navigate to Monterey. Let's go back to Monterey, the map of Monterey, California. Notice the northbound link exiting Monterey, California. See this here? Okay, now it says navigate up one level to intercity. So let's hit this button again, back level, and notice it now says intercity. And we have LA over here and the Pacific Ocean and the Hawaiian Islands over here. And it says you'll see a representation of the physical links between the home in Monterey and Oahu Island where the server for the University of Hawaii is located. Notice that the link first goes from Monterey to San Jose and then LA. So it's going from Monterey to San Jose to LA and then across the Pacific Ocean to Honolulu. Click San Jose. Notice that there are 3 buildings, each labeled with a part of the domain name discovered in the traceroute output. Routers with the same domain name are located in the same building. Investigate each building, router, and interface to complete the following table. Now we're going to work on filling out this table. Hop 5, what they're talking about here is move up in the lab here and see hop 5. Here's hop 5. It says it's in Santa Clara.ca. So let's go ahead and click on Santa Clara. We've got a router here and it's got under interface gigabit Ethernet 00, that's the interface name. I want you to write out the IP address for it. It's that first one in the list, 10.151.78.177. That's hop 5, and the domain name is that device name at the top, RAR01.Santa that whole thing up through Comcast.net. Okay, so that's hop 5. Do the same thing for the rest of these. Go find hop 6. I'll get you started on that one. Hop 6 is in Sunnyvale, so we need to get out of Santa Clara. So back out of Santa Clara and go to Sunnyvale, and that address ends in 121. So that's this top device. So fill in the information onto the table for that one. Okay, I will let you finish that on your own. Move back down to where we're working on this. What is the building router interface and IPv4 address for the outbound link to LA? So let's back out of this. We want to go to outbound to LA. That was this Great Oaks one. And it is in the bottom rack. I want you to hover over that, and you'll see that. So it's the last cable. It's the G1.0, and the address is 172.16.20.254. And let's move back over to the lab here. It's talking about an IXP data center. It's an internet exchange point. It's typically a co-location center that houses ISPs and other customers with the purpose of connecting with one another. At some point, an ISP like Comcast will need to forward the packets to another ISP, and this usually happens in an IXP. So that's information about that. Let's look at step 7 here. You can read the rest of that on your own. Investigate the link between Comcast and Internet 2. The last hop within the Comcast ISP network before packets are forwarded to another ISP occurs at hop 9, and they've reprinted it for us here. Again, Comcast gives a clue where the router is located. However, the domain name is not indicating a city, but an address. So it's saying 9 Great Oaks. Search the internet for 9 Great Oaks, California, and you will find that an Equinix data center is actually located at 9 Great Oaks Boulevard in actual San Jose, California. And you could search for that address using Google Maps if you want. It is an IXP. I'll let you read some more of this on your own, because in part C we get to, in Packet Tracer, navigate to San Jose. So let's click this. We're back in San Jose. We want to go to 9 Great Oaks, CA. Notice the name of the third router in the rack indicates it belongs to Internet 2. This router is the 10th hop in the trace route output, and they print it here. What is the interface for the 10th hop? Well, what's getting us to that .141? It is Gigabit Ethernet 0/0. Part 8, investigate Internet 2. Internet 2, is this a new version of the internet? No, Internet 2 is a non-for-profit ISP. It's a consortium of research, education, industry, and government communities that provide high-speed network services that are tailored for research and education. So go ahead and search the internet and find out what Internet 2 is all about. And it says here, for fun, search for "this man launched a new internet service provider from his garage." And go ahead and read what that's all about. We've got a question here in step 8. What speed is the internet backbone that provides connections between its members? And if you search around the internet there, you will find it's 10 gigabytes per second. All right, step 9, investigate the link to Los Angeles. Our trace route reveals that the next hop is another Internet 2 router. Luckily, the domain name provides us with this information. So a search of Internet to router proxy may help you verify that the LOSA in the domain name indicates this Internet to router is in LA, California. And they were traveling southbound about 350 miles to LA, California. So in Packet Tracer, navigate to the inner city level and then click LA. So let's go back. We got to go back again. Here we are at intercity, and we want to go to LA, so click on LA. The LOSA.net building is located somewhere in LA County. Click the building to enter it. Here we are. You can see where we are right here. The rack has one router which is connected to the San Francisco Bay Area and a submarine cable that crosses the Pacific Ocean. What is the interface used for the 11th hop? So we're talking about this one here. Let's look for something with this number. What is using that .255 as the last number? It is Gigabit Ethernet 0/0. Step 10, investigate the link across the Pacific Ocean. The last hop in the trace route, we've got it listed here as the 12th hop. Although there is no domain name information provided, there are two pieces of interesting information here. I am going to let you read all of that because we get to questions right here in part A. Search the internet for a submarine cable map and see if you can locate any submarine cables that have a landing point both in Hermosa Beach in Hawaii. How many submarine cables terminate at Hermosa Beach? I think there's one, but you can go ahead and search all of this information. What is the name of that one? What is the name of the landing point? How many submarine cables terminate at this landing point in Hawaii? So go ahead and search all of that. It's an interesting thing to look up. The CUS cable was done through a partnership between the University of Hawaii and RAM Telecom International. Search for underwater cable speeds, UH connections across Pacific, to find an article about it. There are some cool videos you can look up for that. In Packet Tracer, navigate to the intercity level. So we're going to back up again. Here's intercity. Follow the cable across the Pacific Ocean. Two repeaters are shown here, although there would be dozens more. Search the internet to find how many kilometers separate each repeater on a submarine cable. When I searched the internet, I found out it was about 62 miles. You can translate that into kilometers if you like. Click Honolulu. You are now on the island of Oahu. Notice that the submarine cable terminates at Makaha. So here it is over here. Click the I2PX-Hawaii building. In the rack are two routers. The first one belongs to I2PX and represents the 12th hop in the trace route output. What interface is assigned to the 12th hop? It is the one that ends in .134, so it's G00. Step 11. Investigate the link between Internet 2 and the University of Hawaii network. The next hop in our trace route is 13, and here are the details. And it indicates it's part of the University of Hawaii. In Packet Tracer, notice that the second router in the I2PX Hawaii rack is called Colanut-RE0. What interface is assigned to the 13th hop? And that one is the G00 172.30.205.29. Step 12. Investigate the last known IP address in the trace route output. So I'm gonna skip this part here. I didn't have very good luck with that when I did it. But they've got a real world output listed over here. And you can go ahead and read through the end of this lab. There's really nothing else for us to do besides reading it, and I'll let you do that on your own. And I hope this helped you get through this lab, where it can sometimes be confusing in navigating between all these different things on the map. I'll see you in the next lab.